Hello, today we are going to discuss about the computer software. What is a computer software? Software is the product or set of instructions. Anything that can be stored electronically can be called as software. What is software engineering? Software engineering encompasses a process, a collection of methods that is nothing but practice and an array of tools that allow to build high quality computer software. Software examples. We can see the different explorers, web browsers. Software's dual role. Software is a product. At the same time, software is a vehicle for delivering a product. Definition. Software is defined as instructions, programs that when executed provide desired function. It is also defined as data structures, enable the programs to manipulate information. Descriptive information, documents, describe the operation and use of the programs. What are the characteristics of software? Software is developed or engineered. It is not manufactured in the classical sense. Software does not wear out. However, it deteriorates due to change. Although the industry is moving towards component-based construction, most software continues to be custom built. Here you can see the failure curve for hardware. In the x-axis we have the time and in the y-axis we have failure rate. So the starting infant mortality, the last point you can see it is going to wear out. So as the time is going to pass, we can see that the hardware is going to wear out. So coming to the failure curve for software, if you see the failure rate, the change may be the major cause for increased failure rate due to side effects. The actual curve is like this, but due to the change that is going to happen, the failure rate is going to increase due to the side effects. You see this one, which is in the thick representation, is the idealized curve. Next, what are software application domains? Software applications are system software, collection of programs written to service other programs. Application software, standalone programs that solve a specific business need. Engineering or scientific software, number crunching algorithm. Embedded software resides within a product or system and is used to control the features and functions for the end user and by itself. Next, product line software, designed to provide a specific capability for use by many different customers. Example, word processing, spreadsheet, multimedia, database management system, etc. Web apps. Web applications are shortly called web apps. This network-centric software category spans a wide array of applications. Next one is artificial intelligence software. Makes use of non-numerical algorithms to problems. What are the new challenges? Open world computing, wireless networks and distributed computing, net sourcing, web as a computing engine and content provider, simple architecture across www, open source, free source codes open to the computing community. Legacy software. Legacy software are older programs that are developed decades ago and have been continually modified to meet changes in business requirements and computing platforms. The quality of legacy software is poor because it has inextensible design, convoluted code, poor and non-existent documentation, test cases and results that are not achieved. As time passes, legacy systems evolve due to following reasons. The software must be adapted to meet the needs of new computing environment or technology. The software must be enhanced to implement new business requirements. The software must be extended to make it interoperable with more modern systems or database. The software must be re-architected to make it network environment. Here you can see the mind map, how the software application domains are interrelated. If you see the embedded software, web applications, artificial intelligence software, system software, application software, engineering scientific software, and the nature of software, legacy software, characteristics of software. Software continues to be custom built. Application to build custom software and mobile apps. So here the nature of software has been evolved, the characteristics of software. Software is developed or engineered, software does not wear out, software continues to be custom built. Software application domains are system software, application software, engineering scientific software, embedded software, product line software, web applications, artificial intelligence software. New challenges are open world computing, net sourcing, open source, legacy software. So what are the stimulating questions we have? Can you differentiate computer program and computer software? Program is nothing but a set of instructions, whereas software is a set of programs. That is, a computer program is piece of programming code which performs a well-defined task, whereas software includes programming code, its documentation and user guide. So when you know programming, what is the need to learn software engineering concepts? A person who knows how to build a wall may not be good at building an entire house. Likewise, a person who can write programs may not have knowledge of other concepts of software engineering. The software engineering concepts guide programmers on how to assess requirements of end user, design the algorithms before actual coding starts, create programs by coding, testing the code and documentation. So, software characteristics. To gain an understanding of software, it is important to examine the characteristics of software that make it different from other things that human build. What are some of the software characteristics? Software is engineered or developed, not manufactured in the traditional sense. Software does not wear out in the same sense as hard. In theory, software doesn't wear out at all. But what happens when changes are requested in the software? You can see in the graph that is going to show over the time period, if there are any changes that are being requested in the software, then there is a increased failure rate due to the side effects. So as and when you don't change the software, the curve will be uniform. The curve will be having no failure rates. Most of the software is custom built, rather being assembled from existing components. What are the software components? As the engineering discipline evolves, a collection of standard design components are created. Standard screws and circuits are only two examples of thousands of components that are used by mechanical and electrical engineers. The reusable components have been created so that engineers can concentrate on the truly innovative elements of the design, that is, new parts of the design. In hardware, this process is very common. In software, this process has yet to be achieved on a broad scale. Reusability is an important characteristic of a highly software component. A software component should be designed in such a way that It should be reused in many different programs. In 1960s, scientific subroutine libraries that were reusable were built but with limited domain of application. Software components are built using a programming language that has a limited vocabulary, well-defined rule of syntax and semantics. At the lowest level, we have machine language. At the middle level, we have C, Pascal, etc. to produce procedural program. At the highest level, we have languages that use a graphical description of the program. When we produce a well-maintained documented code, it's easier to understand and there will be efficient use of memory and vice versa. Mid-level languages are machine independent. After a long period of time, languages like C, COBOL are still in use. Machine assembly, C, Pascal, etc. are referred to as third generation language, procedural language. Fourth generation language moves software developer even further. Non-procedural language, we only specify the desired result rather than the complete detail. Types of software applications: system software, real-time software, business software, engineering and scientific software, embedded software, AI software, personal computer software. What are software myths? Here, according to Pressman, he describes a number of common beliefs of some software managers, customers, and developers believe some false statements. These myths as misleading attitudes. So we can see the types of software myths are manager's myth, developer's myth, customer's myth. Management myth. What is the myth? We already have a book that is full of standards and procedures for billing that provide my people with everything they need to know. What is the reality is the book of standards may very well exist, but is it used? Or does it reflect modern software engineering practice while still maintaining it? My people have, another myth is, my people have state-of-the-art software development in computers. Reality is it takes much more than the latest model in developing the software. Computer-aided software engineering principles can be used. The hardware for achieving a good quality and productivity. And what is the another myth in the management myths? If we get behind schedule, we can add more programmers and catch many more. What is reality is software development is not a mechanical process like manufacturing a product. Okay, so we can do it later. It is not at all acceptable. And another myth is if I decide to outsource the software project to build it. What is the reality if an organization does not understand how to manufacture the software project, to handle the software project internally, it will be invariably struggle when it outsource. What are developers myths? Myth number one, once we write the program and get it to work, our job is done. But what is reality? Someone once said that the sooner you begin writing code, the testing should be done. Industry data indicate that between 60 and 80% of all the effort expended after it is delivered to the customer for the first time. That means when you are delivering the product for the customer, you don't think that my work is completed or my job is complete. But actual 60 to 80% of all the effort or the expenditure that we are going to spend will start after the customer receives the product itself. Next, what is the next myth? Until I get the program running, I have no alternate. So here, what is the reality? One of the most effective software quality principles, inception of a project. That means the formal technical review should be performed. It need to be found to be more effective than testing for finding. So how many formal technical reviews you are going to consider? Next, what is the myth? The only deliverable product for a success. Next, customers myths. What is the customer myth number one? A general statement of objectives is sufficient to begin writing programs. For details later. Reality is a poor upfront definition is the major cause of failed software. Enabled description of the information domain, function, behavior, performance, constraints and validation criteria is essential. These characteristics can be done through communication between the customer and developer. Thorough communication should be established between the customer and developer, because what is the developer is going to develop that software product should be known timely, time to time to the customer. And another myth, project requirements continually change, but change can be easily accommodated, software is flexible. But what is the reality? It is true that software requirements change, but at which time it is introduced, it should have no effect. You can see the layered technology. We have different tools, methods, process and quality. First of all, whatever the software engineering we are going to consider, it is a layered technology. Quality focus, main focus should be on quality. Main principle of software engineering is quality focus. An engineering approach must have a focus on quality. Total quality management, TQM, Six Sigma, ISO 9001, 2015 or this CMMI and similar approaches encourage a continuous process. What are the methods? Software engineering methods provide the technical how-tos for building software. Methods encompass a broad array of tasks that include requirements, analysis, testing and support. Software engineering methods rely on a set of basic principles that govern each and every modeling activities and others. Next, what is software process framework? A software process can be considered as a roadmap to building high quality software products. A software process provides a framework for managing activities. It adapts to meet needs of software engineers and managers. What is a process? Sequence of steps required to develop or maintain. Characteristics. Prescribes major activities. Constraints and controls applied to activities. Here we are going to see the software process as a process framework, that is umbrella activities, framework activity number 1, framework activity number n. Here we are going to see the software process. In the process framework, umbrella activities are there. In the framework activity number 1, software engineering action number 1, what is the task sets we are having? Set of tasks, work products, quality assurance points, project milestones, software engineering action number 1. What are the task sets that we have? That means here we are dividing them to a set of tasks. Next, framework activity number n, software engineering action n1. So what is the common process framework activities we have? Communication. Communication with customers, stakeholders to understand project requirements for defining the software features. And planning is very important. Modeling. Creating models to understand requirements and shows design of software to achieve requirements. Next, constructions. What are umbrella activities? Software project tracking and control. So assessing progress against the project plan. Take adequate action to maintain schedule. Formal technical reviews. Assessing software work products in an environment to uncover and remove errors. Software quality assurance. Define and conduct the activities required to ensure software quality assurance. Next, software configuration management. How do you configure? How do you manage? Reusability management. Define the criteria for work product reuse. Mechanisms to achieve reusable components will be there. Measurement. Define and collects process, project and product measures. Assist the team in delivering software that meets the customer's needs. Next, risk management. Assesses risks that may affect the outcome of project. And last topic in this first unit is capability maturity model integration. What is CMMI definition? CMMI stands for capability maturity model integration. It is a process improvement approach that provides companies with the essential elements of an effective process. CMMI is a good guide for process improvement across a project or organization. CMMI is formed by using multiple CMM processes. Areas in which CMMI addresses are system engineering, software engineering, integrated product training, software acquisition. Structure of CMMI model. The basic building blocks in every CMMI model are called process areas. A process area describes what those using an effective process do. What are the practices and why they do these things. Goals. CMMI model representation. Here, process areas can be organized into one of two representations. Continuous representation and staged representation. You can see here, continuous representation is going to be like this. In the x-axis, we have taken the process, and the y-axis capabilities. So it is a continuous thing. Next, coming to the staged one, organized, that is layer by layer, one after the other. Staged representation uses maturity levels to measure process improvement. Predefined sets of process areas define an improvement path for the organization. Group of process areas, maturity levels range from 1 to 5. Maturity levels apply to an organization's overall maturity. That means overall development of an organization can be done by the help of these maturity levels. Continuous representation uses capability levels to measure process improvement. Continuous staged provides maximum flexibility for focusing on specific process areas according to business goals and objectives. Capability levels measure maturity of a particular process across an organization. Range from 0 through 5. What are the maturity levels in staged representation? Here we can see the first one is initial. The process is unpredictable, poorly controlled and reactive. That is in the first initial step. In the second, managed. Process characterized for projects and is often the reactive. What is the third step? Defined. Process characterized for the organization and is proactive. What is the fourth one? Quantitatively managed. Process measured and controlled. And what is the last one? Fifth one, optimizing. Focus on continuous process improvement. If you see the first one, what is the first maturity level? Initial. At maturity level 1, the processes are usually ad hoc. That means the organization usually does not provide a stable environment. Development is completely chaotic with budget and schedules often exceeded. In this scenario, we can never predict quality. Coming to the maturity level 2, that is managed. At maturity level 2, an organization has achieved all the specific and generic goals of the maturity level 2 process areas. In other words, the projects of the organization have ensured that requirements are managed and that processes are planned, performed, measured and controlled. In the managed level, basic project management is in place. But the basic project management and practices are followed only in the project level. Maturity level 3, defined. At maturity level 3, an organization has achieved all specific and generic goals of the process areas assigned to maturity levels 2 and 3. In the previous level, all good practices and processes were done at project level. In this level, all good practice and processes are brought to the organizational level. At maturity level 3, processes are well characterized and understood and are described in standards, procedures, tools and methods. An important distinction between maturity level 2 and 3 is that at level 3, processes are described in more detail and more rigorously than at level 2 and are at an organizational level. Maturity level 4, quantitatively managed. At maturity level 4, an organization has achieved all the specific goals of the process areas assigned to maturity levels 2, 3 and 4. At this level, processes are controlled by using statistical and other quantitative techniques. Product quality, process performance and service quality are understood in statistical terms and are managed throughout the life of the process. Maturity level 4 concentrate on using metrics to make decisions and to truly measure whether progress is happening and the product is becoming better. The main difference between level 3 and 4 is that at level 3 processes are qualitatively predictable. Level 4 addresses cause of process variation and take care of the action. And coming to the maturity level 5, that is about optimizing. At maturity level 5, an organization has achieved all the specific goals of the process areas assigned to maturity levels 2, 3, 4 and 5. Maturity level 5 focuses on continually improving process performance through both incremental and innovative technological improvements. In this maturity level 5, processes are continually improved based on an understanding of common causes of variation within the process. This is like the final level. Defects are minimized, products are delivered on time within the board. CMMI different from other modules. CMMI provides a way to focus and manage hardware and software development from product inception through deployment and maintenance. It is a process improvement method. It talks about process, that is what process means to a company and how good a process is. And CMMI versus Agile, very important. The main goal of CMMI, capability maturity model, is organizational improvement. It is focused on existing process. Through observing the existing behaviors, CMMI informs the team about their current performance and strengths. Coming to Agile, Agile is a software development methodology that breaks down the development process into iterations, known as sprints. The goal of each iteration is to produce a shippable product that can be handed over to a customer. The most popular Agile methodology type is called Scrum. What is the difference between CMMI and Agile? The application. Coming to the application, CMMI is a process improvements, concentrates mainly. Whereas Agile software development. The main focus of CMMI is on existing process, whereas the Agile main focus is new process and products. What is the main goal of CMMI is organizational improvements. Agile is shippable product. What are the advantages of CMMI model? Develops efficient process in organizations, allows process improvement in organizations. A well interpreted, developed and properly followed process will increase the ability to meet project goals and improve profitability, increased productivity, on-time deliveries, increased client satisfaction, improved cycle time and quality, increased return on investment. What are the disadvantages of CMMI model? May require additional resources and knowledge in smaller organizations to initiate CMMI based process improvement. Another disadvantage is it may require considerable amount of time and effort for implementation. Example, you can take Boeing Space Transportation System software. Boeing is a famous aerospace company. The transportation system software, after CMMI level 5 assessment, achieved 140% increase in general productivity. Elimination of defects prior to release increased from 94% to 100%. It is great achievement. What is the conclusion that we can give is CMMI capability maturity model is a model for process improvement from which organizations will abstract and create process improvement solution that fit their unique environment to achieve specific organizational goals. CMMI is a framework of best practices. It describes the characteristics of good process and provides the guidelines for companies developing their own process. Thank you.